Minerals. Minerals are the building blocks for rocks. They come in many different colors and have many different characteristics, but there are 5 requirements that all minerals must meet, otherwise it's not considered a mineral. First, they must be naturally occurring. They must be inorganic, solid, with a specific chemical composition, and a crystalline structure. But what does that mean? First, naturally occurring means that it formed without human intervention. So anything we dig out of the ground or anything that grows, these are natural. Things that are not natural are anything that humans make: plastic, glass, ceramics, pottery, man-made diamonds, steel. So the ones on the left here meet the requirement to be a mineral, this requirement, and the ones on the right do not meet the requirement, so these could not be minerals. Next is inorganic. Inorganic means that it is not now and has never been living tissue. It wasn't made by any living creature. Inorganics would be metals, glass, if it's sand melted by lightning, not made by humans, most rocks, salt, steel, those are inorganic. Organic include fossil fuels. They are called fossil fuels because they are made of fossils. So they were once living, usually plants or from a swamp. Anything from a plant or animal or made of plastic is considered organic, so cannot be a mineral. So the ones on the left meet the requirement of inorganic, but remember that steel, since it is man-made, does not meet the requirement to be a mineral. Alright, specific chemical composition means that it was described with an exact chemical formula, not a mixture. Things with a specific composition include salt, which is sodium chloride, NaCl, quartz, which is SiO2, metals, sugar, coal, anything we can describe with a chemical formula. The ones on the right, though, have no specific composition. Cookies, for example, are mixtures of sugar, salt, eggs, butter, a bunch of other stuff. And depending upon which type of cookie you're making, you may have entirely different quantities of each item. So it can't be considered, you can't make a chemical formula for a cookie that will be correct. Granite is another example. That's this rock here on the right, often used to make countertops. It has, you can see in it, several different minerals. The black is usually hornblende, the pink is usually a type of feldspar, clear is quartz, but sometimes there's more feldspar and less quartz. Sometimes there's more quartz and less hornblende. So there's no one specific chemical formula for granite, so it cannot be considered a mineral. Finally, minerals must have a crystalline structure, meaning they grow crystals in a specific shape, which is based by their chemical composition. Crystallines include diamond, quartz, gold, pyrite, salt. Coal and glass, though, are not crystalline. So you see in this diagram, this is the atomic structure of crystalline SiO2, quartz, and you can see it's a very regular repeating pattern. That is a crystal, or a series of crystals. Whereas on the right, glass that's pure melted silica dioxide, which is unusual, most of the time it has lots of different stuff in it, is not any sort of a regular pattern. Sometimes it's fitting together very loosely, other places it's fitting together tightly. There's no definite repeat. It's what we call an amorphous solid. It is not crystalline. So these cannot be minerals, whereas this could be. So putting that all together, minerals must be naturally occurring and inorganic and solid and have a specific chemical composition and have a crystalline structure. So looking at some options, you can try and decide whether you think they are minerals or not. And here's the answers. Quartz, yes. Coal, no, it was a fossil fuel, a clamshell, once living. Garnet, yes. Gold, yes. Shark tooth was once alive, and so forth. Now, how do minerals form? There are 3 primary ways that minerals form. They can form from solidifying magma, pressure, or evaporation. Magma, that's when you have molten rock, magma or lava, and it solidifies, creating a solid with many different minerals in it usually. It doesn't tend to be pure. You can see that in this image. Pressure. Sometimes rocks are put under intense heat and pressure, not enough to actually melt the minerals, but enough to change the chemical bonds between them. So it actually does change into new minerals. An example is garnet, which is the birthstone for January, you may recognize. It is only formed under pressure. Finally, we have evaporation. As you can see in this little toy, there was a liquid in the bottom filled with all sorts of different minerals. It was a solution. And then slowly over time, the water is absorbed by the paper tree and then is evaporated into the air. The minerals then are left behind and growing crystals. Salt water does the same thing. This is how we get rock salt, when seawater evaporates, leaving behind the salt. And that is one major way we get minerals.